Laplace. Initial value problems. I took a picture of this because we were in class and then we ran out of room, or time, and my picture was blurry, so let me just walk you through this. Well, what did we have? We had y prime prime minus 2y plus 2y. Oh, there should be a prime on there, shouldn't there? Oh, there was. And that's equal to the cosine. And the initial values that they give us is y naught is 1, and y prime naught is nothing. So, what do we first do? We Laplaciate. That's not a real word. We take the Laplace. It's linear, so I pass the constants out, and the Laplace of the sum is the sum of the Laplace. And then what? We evaluate these Laplace. Guys, alright, so that's from your book. What? That's s squared times the Laplace of y minus s y naught minus s to the 0 y prime naught. Then we expand this guy. It was one tick, so I'm going to have two terms. And that's minus 2 times s, because that was the first derivative, so it's s to the first, okay? And then minus y naught. Then I'm going to add to it 2 times the Laplace of y. Why? Because. And the Laplace of the cosine t, great. Now we're going to go into our S world. Boom, no. Now we're going to use our initial conditions. That's what they gave us up here. They gave us that y naught was, or y of 0 is 1, and y prime of 0 is 0. So, everywhere I see a y naught, or y of 0, that's 1. That's why I put the 1 there. Then, y prime of 0 is 0, and I keep on keeping on in that same fashion. There I see a y of 0, so I put a 1, and that's plus 2 times the Laplace of y, that's equal to, now here's the good part, the Laplace transform for cosine t is s over s squared plus 1. Now what? Step 4, we're going to solve for the Laplace transform. I factored everything that had a Laplace in it, I took out the Laplace of y, and it was left over with s squared minus 2s plus 2. Then what? I subtracted, or I added the s to both sides, and I subtracted the 2 to both sides because those didn't have any Laplace. Now what? I'm going to go ahead and I'm going to add those fractions on the right-hand side. Getting a common denominator, I find that's s to the third minus s squared plus 2s minus 2. And that's all over my common denomination. Now I'm going to go and I'm going to divide both sides by that s squared minus 2s plus 2. I did that right over here. Bam, that's that. Alright, then I need to use partial fractions. Bam, I broke it up like that because those are quadratic non-factorable factors down there in that denominator, so I needed a linear factor on top, yes. So then I added fractions right there, alright? And then I multiplied them out and I gathered like terms down there, boom, because I factored out my s to the thirds, and I factored out my s squareds, and then I factored out my s, yes. And then I had that constant term, which led me to this system. Why? Because I'm setting the constants, like that's a 1. That's why this business down here, well, this business, back, is equal to 1. And then that is a minus 2. That's why that business is equal to minus 2. And that is a 2, and that's why that business is equal to that 2 right there. You see what's going on? Okay, now I got that system, let's solve it. So I go ahead and I rewrite it, because I want to try to find out what my A, my B, my C, and my D are. Alright, so I'm going to use substitution. Put me in, coach. I see 1 minus A is that guy, and D turns out to be a minus 2 minus 2b. Now follow me, I take that C and I'm sticking it in there. And we can see with the colors that that's that new equation. Then I take that D and I stick it there. And do damage. So I got that right there. Okay, we clean up both of those guys and we see that I have that for my first equation. I clean up my bottom one and I got that for my second equation. Now I can use substitution or elimination, but I see that my B is a minus 2A. Yay, I stick that right there. And when I do, I find my A is going to be, yes. No. Finish. Yeah, there you go. A is 1/5. Now that I got my A, I'll put it right there. My B is minus 2 fifths. Now that I got my A and my B, I stick my A right there, and I see my C is 4 fifths. Now that I got my C to be 4 fifths, I stick my B right there, and I got D is minus 6 fifths. Now what? Now that I got my constants, let me rewrite what we have here now. This was my Laplace. Then I did partial fractions. I found my A, my B, my C, my D. That's that. There. Okay. Yeah. What? I'm going to replace my A with 1 fifth, replace my B with minus 2 fifths, replace my C with 4 fifths, and then I replace my D with minus 6 fifths. Now what? It's time to look at our charts. And when we match it up, we see that the only ones that look kind of similar because of that, that look kind of similar is the sine, the cosine, e to the at sine bt, e to the at cosine bt. Now, you might not be able to see the cosine because of that big old freaking hand. Anyway, man, I'm going to try to manipulate this guy so that I can get those forms. The first two are easy. I'm going to go ahead and I'm going to separate that into 2 different fractions. Bam. That's the expansion of that guy. 2 different fractions because I'm going after the sine and the cosine there. The next one's a little bit trickier. Why? Because I need to complete the square in the denominator. Then, when I take half the middle coefficient squared, add it and subtract it, it factors into that. Let's rewrite what we have there. So, okay, now, here's where things start to get fun. I'm trying to manufacture the s minus a all over s minus a squared plus b. So, I need to get that 6 fifths to be a 1, or I need that 6 fifths to be a 4 fifths. That's why I'm adding 2 fifths and subtracting 2 fifths. Because when I take 6 fifths and add 2 fifths to it, I get 4 fifths, just like that. Now what? I'm going to separate it into 2 different fractions, and that's what happened in there. Why? Because when I factor out the 4 fifths from that term, I have that form proper. When I factor out that minus 2 fifths, I have e to the at sine bt proper. So now we can inverse Laplaceate everything. Boom. So that's 1 fifth. That's the cosine. Yeah. Then this one. That's minus 2 fifths. That's the sine. Yeah. Then that's 4 fifths. Whoa. E to the t cosine. Then minus 2 fifths e to the t sine t. And then we all done but the box and flower.